G'day again. Question 9. The complex number z satisfies absolute value z minus 1 equals 1. What is the greatest distance that z can be from the point I on the Argand diagram? Well, as soon as it mentions an Argand diagram, let's draw it. So that's y, that's x. Z minus 1 equals 1. Well, this is a distance that's going to equal 1. If you get absolute value of z, if you just had that one, equals 1, you know that's a circle based in the centre with a radius of 1. So it would look like that. Well, this is also going to be a circle with a radius of 1. It's just that the centre of the circle is going to move. You can easily think about it. If you've got x plus iy minus 1 equals 1, just move that onto the real side. So you've got x minus 1, that's your real section, plus iy equals 1. So in this domain you could write it as, Pythagorean type thing, like x minus 1 squared plus y squared equals 1. You could do it like that or that, doesn't really matter. Either way, if you consider them separately. So x minus 1 is 1. Well, if y is 0, so let's wipe that out. Y is 0, x minus 1. The absolute value of this is 1. Well, x is either going to be 0 or x could be 2. 2 minus 1 is 1. So that could go from 0 to 2. So that's your x value, is going to go from 0 to 2. So I would be drawing that in. So there's 1, there's 2. And then what's y? Well, pretty obviously y can go from I to minus I, because either way you're going to get absolute value of y squared, or in this case, plus or minus 1 there if you express it like that. It doesn't really matter which way you want to express it, as long as you can think through, well, that's going to be, so your y is going to go from minus 1 to plus 1. As long as you can think that through, however your brain is working, then that's fine. So if this must be true and this must be true, then obviously it's moved over here. So your circle, whoops, hopefully that's sort of a circle, looks something like that, a bit wobbly. Now what we want the distance of this, the greatest distance from I, well where's I? There's I, right there, I equals 1. So the greatest distance from here is going to go actually through there to the other side of the circle. What's that distance? That's the radius, that equals 1. What's that distance? That's the radius, that equals 1. So you go 1 plus a bit, and each of those is bigger than 2. I mean, if you root 5 is 2.2, that's 2.8, and that's 2.4. So your answer is going to be one of those. It's not going to be 1, it's going to be 1 and something. It's going to be 2 and something else. The hint is obviously there. That's 1, so therefore that's root 2, and you probably figured that out while you were looking. It's root 2 plus 1. So your answer is D. G'day again. Question 10. Consider the expansion of 1 plus x up to x to the n multiplied by 1 plus 2x plus up to n minus 1 to x to the n. What is the coefficient of x to the n when n equals 100? So to do this question, I would just break it down, start off with 1, do 2, do 3, look for a pattern and try and figure it out, and it should become obvious, okay, because you should have done something like this before. So let's do that. Let's start off with 1. So if you have 1 plus x multiplied by 1 plus 2x. So this is for, we'll say n equals 1. We've got this. So what are you looking for? You're looking for the x value. So 1 times x is 1, 2 times x, so I'm going to give 1 plus 2 equals 3. Okay, there's going to be a 3 in front of the x value. So let's look at n equals 2. So n equals 2, you're going to have 1 plus x squared multiplied by 1 plus 2x plus 3x squared. And you notice here I'm not putting in front of the x, I'm just simplifying there. And I'm not worried about the rest of the equation. Okay, so here I'm looking for the x squared value. Here I was looking for the x value. Here I'm looking for the x squared value. So I'm going to have 1 plus 2 plus 3. So 1 plus 2 plus 3 equals 6. It's going to be a 6 in front of the x squared when you do this. Okay? So that's for n equals 2. Now you should be able to look at that and go, I don't need to go any further. If you do, you know, you can write it 1 plus x squared plus x cubed, 1 plus 2x plus 3x squared plus 4x cubed, and then it'll become, you know, blatantly obvious. So you're looking for the number in front of x cubed is going to be 1 plus 2 plus 3 plus 4, and that's going to be the number in, so 1 plus 2 plus 3 plus 4 equals 10. You probably shouldn't need to get to that stage. You probably should have figured it out by here. That's going to be your pattern. Okay, so this is for n equals 2, that's for n equals 3. Okay, so you notice that it's just one more than the n value. So n equals 2, it's one more, n equals 1, it's one more. Okay, we want n equals 100, so it's going to be one more, which is to 101. So if I just use this, and we'll rewrite this, we'll scribble this out so we're not looking at that. So 1 plus 2 plus 3 plus 4 plus up to, oops, should have dots there, dot, 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 plus 101 equals. It's pretty hard to do that in your head or even worry about doing it on your calculator. What I would tend to do would be use a Gaussian equation, okay, which you probably should be aware of. So if you're looking at these numbers, 1 plus 2 plus 3, there's no button, unfortunately, on your calculator to press what is plus. There's a multiplied for factorial, but there's no button for this. But you can use Gaussian by going, okay, I've got 1 plus 100, so I'm going to have 101, plus 1 plus 100, plus 2 plus 99, and all of these are 101. Yeah? And you should be familiar with that sort of thing. So here I've got 50 lots of 101 plus another 101. Okay, 50 lots of 101 is, and we just make me squeeze this in, I'll squeeze it in here. 50 lots of 101 is 5050 plus 101 is 5151. So your answer is C.